All right, so we've been asked to find the antiderivative, and we've been given 4 functions that we want to work with. Find the antiderivative of these 4 functions. So we're going to start with this guy, square root of x, okay? And if you remember finding derivatives, a lot of the same rules and tricks and techniques are true for antiderivatives. So if I take square root of x, I'm going to rewrite this as x to the 1/2 power dx. Now, the antiderivative of x is x squared. Antiderivative of x squared is x cubed. We always add 1 because our derivative power rule says we subtract 1. And then, of course, we got to work out the coefficient. So if I add 1 to that, right, well, 1/2 plus 1 is 1/2, or 3/2. Okay, so x to the 3/2. So that's going to be the first piece that I write down. Now, if in my head I take the derivative of this, the derivative of this would be 3/2 x to the 1/2. Well, there's no coefficient here, so I've got to figure out a way to make, when I multiply 3/2 times this coefficient, to get a 1, right? Because that's what's there, is a 1. And that's going to be a 2/3, okay? 3/2 times 2/3 is 1, and then it'd be x to the 1/2. Cool. Now, the only last step to make other than this, right, finding that coefficient, is if they gave me a square root, then I would like to give them back a square root, okay? So, and you've got to remember, right, this is the equivalent of the square root of x cubed, okay, which is square root of x squared times the square root of x, and that's just an x, okay? So all of that done there on the side. So this guy becomes 2x root x over 3, right? So x cubed under a square root is x root x. And so 2x root x over 3 would be the derivative, antiderivative of the square root of x. Okay? Next one here is integral or antiderivative of 2 over x dx. And I'm going to rewrite this as 2 times the antiderivative of 1 over x dx. Okay? And my reason for that is, again, going back to antiderivative properties. The antiderivative of 1 over x is the natural log of x. Why? Because the derivative of that is 1 over x. So the antiderivative of that is natural log x, and then the 2 just comes down, 2 ln x, and that's it. Okay, 2 ln x. So remember, anytime you've got that constant multiplier, you can pull that out and just ignore it. Okay, and that'll come up again actually in problem number 8. Okay, so let's try number 7 here, right? E to the 6x. Okay, and if you look at our rules that are in my previous video, we said that this would become e to the 6x. Oh my goodness, go back. I forgot. Plus c, right? We don't know where my head is today. We got to add our plus c's. Our plus c's are always going to be there. Okay, so this will be e to this, right? The derivative of e to the 6x is e to the 6x, and then you have to work out the coefficient. Same thing with the antiderivative. The antiderivative of e to the x is e to the x. The antiderivative of e to the 6x is e to the 6x. But if I took this derivative would be 6e to the 6x. So we know that's not the correct antiderivative. How do we fix it? We fix it with that. Okay? Now, 6 times 1/6 is 1e to the 6x. And then what? Plus c. Okay? And if you see my rules from my first video on antiderivatives, that follows the rule verbatim. Okay? How about number 8 here? Well, the first thing I'm going to do for number 8 is rewrite it as 12 times antiderivative e to the 3x dx. Well, I know the antiderivative of e to the 3x is going to be 1/3 e to the 3x plus c. And then I'm going to multiply by 12. Okay? And 12 and 1/3 makes 4 e to the 3x plus c. Okay? And if I took this derivative, right, we're going to say 3 times 4 makes 12 e to the 3x. Right? So this would give me a derivative of this, and the derivative of c would be 0. Okay? So that's finding antiderivatives. And again, you've got to know your derivative rules very, very well to be able to find antiderivatives. So let's do some applications. Let's do some initial value problems. Okay, some initial value problems. Okay, so here we go. We've been given f prime of x, and we've been told find f of x. Okay, so find f of x. All right, how do we do that? Well, we're going to take the antiderivative of both sides. Well, what's the antiderivative of f prime of x? Would be f of x, because the antiderivative and the derivative are inverses. Okay, what's the antiderivative of this guy? Well, the antiderivative of x would be 1/2 x squared. Why? Because that exponent was a 1. It's got to go up to a 2. And when I multiply, right, when I take this derivative, so when I try to go from here to here, I'm going to multiply by 2. Well, I've got to find a way to cancel that out to give me a 1 as a coefficient. So 2 times 1/2 is 1. Okay? And the antiderivative of -5 will be -5x. The derivative of -5x is -5, so I don't have to do anything else to him, plus c. Now, this is an initial value problem because they told me, hey, by the way, here's a fact about this function. They've given me an initial value. Okay? So they've told me f of 1 equals 6. What does that mean? That means when x is 1, y is 6. And I can solve for c. Okay, well, 1 squared is 1 times 1/2 is 1/2. So that's 1/2 minus 5, okay, plus c. Okay, so what do we got here? We got 6 equals 1/2 minus 5 plus c. Well, 1/2 and minus 5 is -4.5. And we're going to add that to this side, so that'll be like 10.5. Okay, 10.5. And you 10.5 or 10.5, or I guess you could do it as a improper fraction. It'd be 21/2, right? So depending on what you're expecting for an answer format, all of those are the same. I think our book that we're using will require that, so that's what I'm going to use, but it doesn't matter what you use to arrive at that, as long as you get it in the correct form in the end. Okay, so c is equal to 21/2, so f of x is now equal to what? Well, it's that function plus c, but I know the value for c now. So it's going to be 1/2 x squared minus 5x plus 21/2. Okay? Boom. Initial value problems. What's the difference between an initial value problem and any other antiderivative? If you have an initial value problem, you're going to solve for c. That's what we know, okay? So here we see again, this is an initial value problem. So we're going to solve for c. Well, first we have to find the antiderivative. The antiderivative of f prime is f of x. The antiderivative of x squared is going to be x cubed. And then I say, okay, well, if I take that derivative, that's going to be 3x squared. Well, I don't have 3x squared, so I've got to get rid of that. So I get that multiplier. And the antiderivative of 1 is going to be x, and then plus c. Now plug in your initial condition. Your initial condition says when x is 0, y is 8. So that's 8, and that's going to be 0, and that's going to be 0. And a beautiful thing happens is that c equals 8. And so f of x is 1/3 x cubed plus x plus 8. And that's our initial value problem solved. Okay? And last but certainly not least, a business application. Marginal cost is given by c prime of x equals x cubed minus 2x. So again, marginal cost is always going to be the derivative of the cost function. It's also the rate of change of your cost. And so let's say you don't have a cost function, but you have calculated your rate of change, your marginal cost. You say, here's our rate of change for our cost function. How do we find our cost function? Well, we write c prime of x equals x cubed minus 2x. And then we can take a different color to show our math, and we can say antiderivative of both sides. Okay, take the antiderivative of both sides. Well, the antiderivative of c prime is c of x, which is your total cost function. Well, this guy here, x cubed, will be x to the 4th, but do the derivative in your head. That derivative would be 4x cubed. I don't have 4 of those. I have 1 of those, so I have to adjust my coefficient. Okay? This guy, negative 2x, is going to be negative, and he's going to be x squared. Take his derivative. 2 times 1 makes 2. Oh, yay, look, that actually worked this time. And then plus c. Okay? Now, they told us our fixed cost is $7,000. Okay? That's this guy right here. In a business equation, these are variable costs. Why? They change based on the number of units you're producing, which is x. Your fixed cost does not have an x value. It is a constant. Okay? So they basically told us c is 7,000. So c of x is 1/4 x to the 4th minus x squared plus 7,000. So there's our cost function. Okay? So there are some initial value problems, both mathematical and business. If you have questions, let me know.